All right, let's look at chapter 1.3, where we will study linear equations in two variables. And if you had to guess, yes, linear equations means that we are dealing with lines. The simplest mathematical model for relating two variables is a linear equation in two variables, the graph of which is a line. In mathematics, it is implied that all lines are straight. If it's not straight, it's a curve, not a line. Slope-intercept form is one of the most common ways to express a linear equation in two variables. I'm sure you guys have all seen before slope-intercept form, y equals mx plus b, where m is the slope of the line and b is the y-intercept of that line. Because that's the y-intercept, that means its ordered pair would be 0, comma, b. The x-coordinate has to be 0 if it is a y-intercept. The slope of the line is equal to the rise divided by the run. To find slope, we need to determine the change in the y values divided by the change in the x values. Right? That triangle there means delta, right? That means change in mathematics. That's delta y over delta x. Change in y over change in x is how we get our slope. Slope-intercept form is convenient in that it makes sketching graphs fairly easy. Simply plot 2 points and connect the dots. Anytime you're sketching a line, it only takes 2 points to sketch that line. So, for example, sketch y equals negative 3/4 x plus 5. Well, looking at this equation, we know what the slope is and we know what the y-intercept is. The y-intercept is the ordered pair 0, comma 5, which we can easily plot on our graph. That is 5 units up from the origin. We also know that the slope is negative 3/4. That means from our y-intercept, we can go down 3 units and then to the right 4 units. Going down 3 units to the right 4 units brings us to the ordered pair 4, comma 2. That's where we can plot our next point. And now that we have 2 points, we play connect the dots and we have a sketch of our graph. The slope of a line is defined as the rate at which the y values change with respect to x. The letter m is used to represent the slope of a line. All of these are different ways of seeing slope. M is equal to change in y divided by change in x. M is equal to rise divided by run. M is equal to delta y over delta x. All of those mean the exact same thing, right? What we are finding is the slope, and another way to write it, as we see here in yellow, the slope of a line passing through 2 points x1, comma y1, and x2, comma y2 is given by m is equal to y2 minus y1 divided by the quantity x2 minus x1. We're taking the difference of the y-coordinates divided by the difference of the x-coordinates. All right, find the slope of the line passing through the points negative 5, negative 6, and 2, comma 8. Well, again, we want to use this formula for slope. y2 minus y1 over x2 minus x1. In this particular case, that will give us 8 minus a negative 6 divided by 2 minus a negative 5. Again, with these formulas, it doesn't matter which point you choose to be x1, y1, and which point you choose to be x2, y2. Just make sure you are being consistent and not mixing up, say, for example, x1 and y2 in the same point. Okay? All right, so we have 8 minus a negative 6 divided by 2 minus a negative 5. We know that when we subtract negatives, they're going to become addition. That leaves us with 14 divided by 7, which we can then reduce that fraction. 14 divided by 7 leaves us with 2 for the slope of our line. All right, write the equation of the line in slope-intercept form. So now that we have the slope, we can begin to come up with our equation for our line. Recall that slope-intercept form is y equals mx plus b. Now we can begin to fill in some of the given information. We know that m is going to be the slope, right? And whenever you guys are writing a standard form for something or an equation for something, you need to solve for all of the constants. Okay, in this case, the constants in the equation that are going to define this particular line are m and b. Constants are always going to stay the same versus your variables x and y. Those are your different values, your different points that are going to be solutions to the equation. So we know that y equals 2x plus b. We have substituted 2 in for the constant m. To finish this equation, we have to find b. To do that, we can use the given information of our points and plug those quantities in for x and y to allow us to solve for b. Now, you can choose to plug in either point that you would like. All right. Notice in this case, I have plugged in the second point. I've plugged in 8 for y and 2 for x. I picked those because they're both positive values, right? Whichever one is going to be, you think is going to be easiest is perfectly fine. So we get 8 is equal to 2 times 2 plus b. To solve for b, we need to subtract 2 times 2, which was b, 4, and we end up with b is equal to 4. Now that we have solved for the constant b, we can put that together into the form of our final answer, y equals 2x plus 4. And here is what the graph would look like. Okay, we have our 2 points, -5, -6, and 2, 8. Again, it only takes 2 points to draw a line. There we have our line. Notice that drawing it in also shows us that we do indeed have the correct y-intercept at 0, 4. Looking at the graph, we can notice that the slope also matches with a slope of 2. We go up 2 units over 1 unit, up 2 units over 1 unit to get to the next point each time. Okay, equations for vertical lines come in the form x equals a, where a is any real number and corresponds to the x-coordinate of any ordered pair on a line. The slope of a vertical line is said to be undefined. For a vertical line, the change in x between any 2 points will always be 0. This means that we are going to have delta y divided by 0 when we attempt to find slope. Know that anytime you divide by 0, you are going to get something that is undefined. Okay, we are not able to divide by 0, and that is why we say the slope of a vertical line is going to be undefined. Here's an example of the line x equals -1. Again, vertical lines always come in the form of x equals some number. All right, that would be this vertical line right here. And you might notice that the x-coordinate of every single point on that line is going to be -1. Similarly, x equals 3 is also going to be a vertical line. And the x-coordinate of every single point on that vertical line is going to be 3. Horizontal lines, all right, come in the form of y equals a, where a is any real number and corresponds to the y-coordinate of any ordered pair on the line. The slope of a horizontal line is 0. For a horizontal line, the change in y between any 2 points will always be 0. If you were to try to find the slope, delta y over delta x, the numerator is always going to be 0. All right, and 0 divided by any non-zero number, right? 0 divided by any non-zero number is equal to 0. For example, we have the line y equals 4. That's going to be a horizontal line where every single y coordinate of that line will be equal to 4. The horizontal line y equals -2. Okay, every single y coordinate, every y point on that line is going to be -2.